Alrighty. Thank you guys for coming to my workshop. My name is Carter, and I'm teaching everyone how to make an MP3 player with the STM32. Before we pardon me, before I start my workshop, I like to say just the STM32 is a wonderful microcontroller, but it is a little bit difficult to work on. So hopefully by the end of this session, you will have a good idea of how to use an STM32. Alrighty. If you have not, please sign in with the QR code. Alrighty, so what is a microcontroller? It essentially is just a small little computer containing every little aspect about a computer. For example, the processor, the memory, the input and output, and a lot of other functions. While microcontrollers are like computers, and they're very small, they can only do very, very simple tasks. They can't run Word, MATLAB, or play video games. Right. And many electronic devices that you use in everyday life, for example, calculators, navigation systems, even microwaves, they all use microcontrollers. Right. So what exactly is the STM32? The STM32 is a microcontroller. It is created by the company ST Microelectronics. It is known for being very reliable, flexible in how and what programming language you use it and all of its applications, and it's very easy to use. I've seen a lot of IEEE members use the STM32 and their fun little personal projects and in capstone design. Many companies use it in professional settings, and it is very popular among hobbyists. And so as you see on the presentation, we have this small little blue board. This is called the STM32 Blue Pill, and we are going to use these in our adventures. Alrighty, so this is our first test. Well, what we're going to do is that we're going to make an LED blink on or off. Now, this doesn't really sound glamorous, but simple tests like these are always good to conduct before you move on to more complex projects. Alrighty, so plan it out. So before we actually get to programming it and physically building the circuit, we always should just prototype it. For example, the picture you see is a schematic created with a program called KiCad. Now, I'm not going to go into the specifics of KiCad, but as you see, later in your professional and hobbyist careers, you will see you'll be creating these schematics to illustrate to other engineers of what you're going to do and how are you going to do it. So this diagram shows us which pin we're going to connect the resistor and LED to the circuit. Alrighty, well, now let's build this. So in order to physically build the circuit on without using a printed circuit board, we have to use a breadboard. And what it is, a breadboard is just a little plastic board with a lot of metal connections that engineers use to prototype circuits. And breadboards use a coordinate system to specify which exact hole electronic component should be put into. Alrighty, so with the first of our parts, we have the resistor. So what a resistor is, it is an electrical device that impedes the flow of current, or to say in more layman terms, it decreases the amount of power in a circuit by changing the electrical power into heat. And you see how all these different resistors have these different colored bands on them. These colored bands, they show the resistance calculated in ohms of the resistor. Now we're not going to get into much detail today. Alrighty, so then we have the LED, and I think a lot of us know when LED is. Electric current goes through the LED and it turns the LED on. So the way an LED is used is there is two legs on an LED, a cathode, which is the longer leg and it's positive, and the anode, which is the smaller leg and is negative. When we build a circuit, we have to connect the anode first and then the cathode. If you swap it the other way, it will cause the LED to reverse polarize and it will go boom. So let's be very careful of that. Alrighty, so power time. So how a circuit is built is that first it's connected to ground, and then all the electronic components are properly placed until it is connected to the voltage source. So for example, we will use one of the pins on the STM32, specifically pin A1 as our ground, and we will then build our electronic circuit, which will then connect to the 3.3 voltage pin on the STM32. Alrighty. So now let me back up, because now we're going to actually physically build our circuit. So I want you to place one end of the resistor onto section A10 of the breadboard. And right now we're going to turn on the light, or Matt's going to turn on the lights. Alrighty. Now, if you could please place the other resistor into A14, or the other end of the resistor. Or pardon me? Where do I place it? You place one end of the resistor onto A10 on the breadboard, and the other end of the resistor onto A14 in the breadboard. Alrighty, I'm just going to go around and check everyone's. All right, thank you so much for coming. Appreciate it. Yeah, that's perfect. All right. Alrighty. Pardon me? Could you please place one, I'm sorry, do you have a resistor? All right. Could you please place one end of the resistor into coordinate A10 on the breadboard? Coordinate 8? A10. A10. Yeah. And could you please put the other leg of the resistor into A14? Hey, thank you so much. Alrighty. Can I see it? Fantastic. Thank you so much. Alrighty, everyone did a fantastic job. All right, now let's move on to wiring the LED. Alrighty. So can you guys please place the shorter leg of the LED, or called the anode, into pin B14? And then please put the longer leg into B16. Feel free to bend the wires. The anode goes into B14. The cathode goes into B16. Yeah, I think that's a good idea. I think I should have done that. Whoops. Alrighty. I'm just going to go around and check everyone's circuit board. That is wonderful. I just want to check. Yeah, no, you did a fantastic Wait, should I done? Hello. Okay, I'm sorry for the technical difficulties. Alrighty. Let me just reset this. I'm sorry about that. Alrighty. So I guess we're all done. I mean, well, for the wiring right now. So now we're going to set it up. So hopefully everyone download the STM32 Cube IDE. If not, just go on just look it up on Google and you'll just be able to download it. It's very easy. Now, can everyone please get their computers out with the STM32 Cube IDE? Wait, do you have it installed? Laptop? Yeah, do you have a laptop with the STM32 Cube IDE installed? No, I have it up. All right. Well, if you don't worry. We'll just take our time. It doesn't matter. I mean, the most important part is that you're all here. Yeah. Now for my virtual for the virtual participants, if you can always come in person, that would be great. Just because you'll have a breadboard that you can use. STM32 Cube IDE. 2 Cube. It's just Cube. Yeah. It's a weird name. Alrighty. Alrighty. Yes, that's it. Now, if you go on the website, there's going to be something that says Get Software. Just click on that. Alrighty. And please just put your email address. Alrighty, how's it going, Justin? Opening up. Should I wait? Oh, did anyone? No messages yet. All right. Should I mute my mic or? Okay. Alrighty. I'm just waiting for everyone to. Damn. It takes a while. It's a pretty big file to download. Joel, right?
Yeah.
All right. Thank you so much for coming.
Open file.
Yep. It's an installer. I think it didn't extract it first. All right. Thank you for downloading it. We will move on shortly.
Cool. That's really good. What are you doing? Yeah, but it only records them. I think the main. And then, so when you switch back over to hardware, you put it on the side. Go switch to your keep it on this one. Okay. How much longer are we gonna give it?
We're almost done. I'm just waiting for everyone to install it.
Okay.
It's kind of a slog since it's like 2 gigabytes to download.
I put that on there, didn't I?
I'm pretty sure.
Let me ask them.
Because you showed me it before. Oh. Okay.
Wait, no, that's the Simon Coleman.
Yeah.
I did. That's the right one? That's the right, one, right? Yeah.
Right? Alrighty, it works. Yes?
After you get to this part, when you say click on the boxes same name.
Oh, yes, that is true. Could you do the one that's above?
This one?
The first one? Yeah, that's true. Yes. For some reason, there's 2 versions of that. And just please click next. And then just follow the instructions. Kubernetes ID, then like.
You have only one choice. Lights. Damn, this old building. This building is like, what, 1953? IEEE Lounge.
Oh, okay. Cool. Alrighty. Justin, can you go in like, pardon me, can you access the STM32 IDE? Oh no.
What's going on? should be it.
You can always just make a new folder. Yeah, maybe it's working. Just say allow access. Yep, yeah, I see it.
This?
No, not that.
Uh,
You just click yeah or something.
okay.
This guy. Perfect. Okay. Well, it seems like everyone has it up. Right, now we will continue on with the presentation. Alrighty. Now I'm gonna shut off the lights and see it. All right. So the STM32 Cube IDE is a program we will use to configure the elements of the STM32 microcontroller and to program it. So could you please open the STM32 Cube IDE and then in the box and make a new project, please. Then in the box it says commercial part number. Type in this, like this name, and click on the box with the same name and click the one that first appears. And then after that, please type in your KuberNet ID and hello world for your project name. So I'm going to wait for everyone to do that, and then we can move on. Thank you. Alrighty. It's loading. It's all good. Right. Alrighty. It does take a while to load. I've realized that the STM32 Cube IDE is actually very, very RAM intensive. I don't know why. It just is. I don't. Right. And for some reason, it also has to connect to the internet. Yeah, it's really slow. Right, and then just click on the first box. Yeah, so this guy here. All right, now I'm going to do this on my computer as well. So we have a live demonstration. File. All right. It's C. Just click OK. All right, this is for all the Zoom kids. And remember to click on the first box. And please click next, and then just say CM Klevik, hello world, and I'm just do this too because I already did one. And just click finish. All right, and while that loads, we will move on to our next topic. So, what is this? What this is, it's a little image. So I'm gonna give some backstory. The STM32 microcontroller allows the user to customize what each of its pins does. And for now, so for example, we're going to use pin PA1, which is right here. And with PA1, we can tell it to receive an input, to output, a value, to message something, to reset the whole chip, etc. We have lots of options. So for now, let's click on pin A1. And then let's click on GPIO output. You see how it says PA1 in green, and now it says GPIO output. It means we've successfully selected that pin. Alrighty. Now we are going to program the STM32 microcontroller. So I'd like to say C is for cool, and the programming language. So C is a programming language widely used in microcontrollers and other forms of embedded systems. And so for now, we will be able to click on main C in the window. And if you can't find main C in the window, just save that file previously, and then a main C should pop up. So I'm gonna go check around for all of our in-person people and see how we're doing. Yes. Yep. Did we save it? Save it. Control S, please. And then just click on yes all the time. Alrighty. Yep. Oh, wait, no. Can you type? Okay, let's just show you. STM32. STM32. F103. C6. T6A. All right, now just click on that first box right here.
This one?
Got it. And please click on next. And Cougar ID and Hello World. And please click on finish. Yeah, just click on yeah.
The commercial part number?
Yep, that's what that was called. That's the part number.
Oh, okay, let me type that. So, see here, what was it?
STM32.
STM32.
F103.
F103.
C6.
C6.
T6A.
T6A.
Yeah, let's do that. And just tell them to click on the first box. Yeah, it takes a while to load. It's weird. Yes, PA1. Bernard? No, he just left.
Yeah. Sorry about that.
output. Alrighty, then please save it. Control S. Yep. Alrighty, seems like everyone has generated code. Now we'll move on to the next step. Right. So now we have to program the STM32, and I'm going to say it is very weird, even for me. So on main C, we will scroll down until you see while parentheses 1. When you find it, please write HAL GPIO toggle pin GPIOA with a comma on one line, and HAL delay 1000 on the next. We will fill in the blanks. We will fill in the blank spaces in the toggle pin function. So I'll wait for everyone to do that, and then I'll move on to the second phase. So while I do that, I will do this as well. Live demonstration. Save. Generate code. Alrighty. I'm gonna scroll down to while 1. We're gonna type in HAL GPIO toggle pin GPIO A. I'm gonna leave that blank, and then we're gonna write HAL delay 1000. All right. Now I will come around and walk around everyone to see how we're doing. Please remember to add semicolons at the end too. Yeah. Thank you. That looks fantastic. How we doing? Guys, HAL GPIO toggle pin. Yeah.
Maybe the other.
I'll be right back. I'm just gonna check Justin's. Justin, how are we doing? Any HAL GPIO toggle in pin. Yeah, just remember to add semicolons. Remember it's C.
Oh, here, right?
Yeah.
Oh, yeah.
Yeah. Remember, this is a type of C, but it's a little bit strange since we're working with HAL, or as people like to call it, the hardware abstraction layer. I'm gonna get. Alright, how we doing? It's toggle pin.
Pin?
Yeah, it's toggle, and just make sure it's like not all caps for this. Like for toggle pin, please make it not all caps. So you do like capital T. And if you could please make that P capitalized. Then type in all caps GPIOA. O. A. And then a comma. Then at the very end, if you can move to the very end, please add a semicolon. And now please do HAL in all caps. Yeah, underscore, and then capital D delay. Alrighty. Parentheses. 1000, and then semicolon at the end. Alrighty. Alright, so we haven't finished our code because we still have to specify what pin it is. So I'm going to ask all the in-person people the question, and people who are online, definitely you should answer it. What do we want to write if what we need to write is GPIO pin and these two little hash maps, where the two hash maps is the actual number of the pin connected to the resistor. So what pin did we connect the resistor to? Can someone tell me? One? Yeah, to the resistor. What pin of the STM32 did we connect the resistor? A1? A1? Did I know the Zoom kids got it too? Right. Alrighty. So, we already specified it's GPIOA. So all we just have to write is GPIO pin. Oh, excuse me. Ah, wow. Okay, hey, we're almost done though, you guys. All right. So we only have to write GPIO pin and then 1. So I'm gonna type it out on my computer for a live demonstration. All right. As you see, it is GPIO underscore pin underscore 1. Justin, is there a way you could ask, or guys, can you does anyone have an STM32 at home or where you are zooming from? All right, so because for this part we're gonna need an actual STM32. So I'm gonna go walk around, make sure everyone's stuff. Fantastic job. Fantastic job.
Does this matter? Like I named it Hello World.
Did you rename it? No, it's just fine. It should be fine. All right. Just hurry. APIO.
Yeah.
Wait. Can I see your program? It's GPIO.
GPIO.
Pin 1.
Oh, do I need to type it in?
Yeah.
All caps, right?
Wait, no. Can you just redo that whole thing?
Which one?
This it's GPIO.
GPIO.
Wait, no, that one's fine. I'm sorry. I mean like the A1.
IO.
So for this, can you just get rid of the A1? We'll do GPIO
PIO.
underscore
Underscore.
pin
Pin.
underscore 1.
Underscore 1.
Yeah, and can you just change GPIO to GPIOA here?
Oh.
All right, fantastic. Alrighty. Justin will send you the code. Thank you, Justin. Greatly appreciate it. All right, now it seems like everyone is good to go, but it seems also everyone does not have an actual STM32. Wait, is that yours? Okay, hold up. But I'm just going to do one thing before that. I'm going to walk around everyone and make sure they have a proper connection to their laptop. Mind if I just do that? Yeah, this part's a little bit weird, so I'm going to go over it in the next lecture or session. Thank you so much for coming. All right, now can you please put that into your computer? All right, could you please uncap the USB port here and place it into your computer? Thank you. Justin, do you see on your breadboard, there's that blue little dongle thing?
Blue little dongle. Yes.
Yeah, you uncap the USB port on the other side of it.
All right.
Big black thing on the, oh, sorry, no. On the other side.
Oh, wait, like the whole thing?
Yeah, just take that cap off, then please insert your computer. And then you will press. I'm going to turn the lights off because I assume everyone plugged it in. Show you. Oh, I am? All right. All right. Is my mic off or? Is my mic off? Okay, cool. All right. Seems like I have to reshare my screen. All people probably got kicked out. All right, seems like we're sharing the screen. Let me go back to my STM32 Cube IDE. And we are going to click this button right here, which is called Run. So it will look like a green circle with a play button on it. I want everyone to please click that. And then just please click OK or yes or whatever it is. Anything positive. Oh shit. Okay, we have that. Okay. And click sorry, do you mind if I take this? It was supposed to I checked for this last time and it should have not done this. Sorry about this. Apologies. Oh. No. Alright, I'm sorry, I'll be right back. I'm just gonna turn the lights on. Is there a way you could press play again? Or run?
Yes, right?
Yes. And try press update and open update mode. Yeah, I don't know why it says that. Sorry, do you mind if I have your mouse? Just to work on it? Should not have happened. Sorry. This happens a lot. There's no logical reason why it does this. Once you do this, it should be all hunky-dory. But this works. So we can close on all the windows and reopen it, please. Yeah, if you guys are getting some kind of update error, I don't know why it does this. I manually updated all the STM32s the day before. Is there a way you could oh, just run for you.
It says no target, no device.
Odd. Okay, so we're connected properly, right? Yeah. Okay, that's a bit strange. So we can try it again. Yes, please. All right. See if it works. Well, congratulations, you did that. Yeah. I know. Although it's just a blinking LED, this means you are prepared to do more complex things. So thank you, Joel. Good job. I will definitely get back to you. I don't know why it's doing this. All the STM32s I did update. You just click OK. Yeah. Oh no.
It requires an update.
Yeah.
Refresh device, right?
Yes, please. Click on open update mode and give you heck. So just like keep on unplugging the silly little thing. Sorry. Try it and please click on refresh device list. Click on the drop down menu and click on whatever's given there. Then open update mode. Yeah, then try press
Upgrade?
Yeah. Or just press refresh device list again and then try update it. Try upgrade. I don't know what you feel.
Alright, this is a bit too long. Right.
I'm more worried if it's gonna work.
No, it's fine. They get to see one.
Nope. I know this, it's really, really, really strange. I never had to do this like until like Tuesday, these things.
Do you have to press something?
No, not for that.
So after mine, it just.
Oh, it's just shutting down exit? Okay, then you're good to go. So we're just gonna move this.
Yeah.
So I'm gonna explain what I did with this in the next lecture. I just want to keep this simple. Congratulations, you just did that. Hey. And this is one of the most annoying microcontrollers to use, but one of the most, I guess, best. All right, so we got to that thing. Save best for last.
I gotta do the whole thing again.
Yeah, it's just you gotta keep on doing this silly thing.
Give it a couple seconds to refresh it real quick.
Yeah, I'm good. So yeah, with that, you just gotta.
Device 4 not found.
Could you click on the drop down menu? So this 232, and then click on that guy.
Only one.
So wait, I could try it. Yeah, I think maybe like click here and then click there. Try that. I had to do this for like an hour.
Alright, let's see here. Let me just replug all the pins real quick.
All right. Do you have anyone in the chat, or I guess not? All right, I guess I'll end the Zoom. I'll just conclude and end the Zoom call, then help everyone else. All right. So thank you all for coming, and you've just successfully created your first electronic device with the STM32. Now in the next lesson, we will graduate from a blinking LED to an MP3 player. So once again, thank you all you guys for coming, and signing off.